Good morning, everyone. This is Henry from A STEM Tutoring, once again attempting to serve as your wise old math sensei. It's a beautiful, sunny Southern California morning. Today's lesson, we will discuss using the derivative to find the velocity at which two people are moving apart. So, let's pretend that a boyfriend and girlfriend have a heated argument. They slam the door and start walking away. One of them starts walking due north at 1 mile per hour. The other person was walking a little bit faster. They're walking due east at 2 miles per hour. So at any given time t, the number of miles walked is t for y of t, or 2t for x of t, the rate miles per hour times the time that's elapsed. How far apart are these two angular levers moving apart from each other? Well, that distance is the hypotenuse of this right triangle. If you recall the Pythagorean theorem, a squared plus b squared equals c squared, where c is always the hypotenuse of the right triangle, and a and b are the legs. So we can write an expression for this in terms of t. C of t equals, actually c squared of t, equals x squared of t plus y squared of t. We can square root both sides. And this tells us c of t, the distance that these two angular levers are apart from each other at any given time t after they've slammed the doors and walked away, equals the root of 2t, the whole thing squared, plus t squared, where I've replaced x of t and y of t with their respective expressions that I can see from this diagram. So we'll start to simplify. Square root of 4t squared plus t squared, combining those like terms, equals root 5t squared. Now we can simplify this further, recognize that the square root of t squared is merely t. So c of t equals t times root 5. If we take the derivative with respect to t of everything, then the velocity v of t at which these two angular levers are moving apart equals root 5. Because remember that a constant times a variable, the derivative is just the constant itself. This follows from the fact that the derivative of ax to the b is ab times x to the b minus 1. This exponent comes out here as a coefficient multiplier, and you subtract 1 from the exponent. Well, t to the 1 becomes t to the 0. Anything to the 0 power is always 1. So we're left with a simple solution that the rate at which these two angular levers are moving apart from each other is root 5 miles per hour, so a little more than 2. This has been a simple example of how to use the derivative to find the velocity at which two objects are moving apart. If you'd like to learn more, I am available for hire as a private tutor. You can see my contact information in red up here at the top. There's my website, there's my email address. And as a thank you for watching all the way to the end of today's lesson, if you mention the code FREEBOOK when you contact me, I will give you a free copy of my book, Smart Suggestions for Student Success, at our first meeting. This book normally retails for $10 on the Barnes & Noble website. And I wrote this book in an effort to give advice and guidance to help students succeed in school, in work, in life. Thanks for watching. Have a great day.